A 33 billion ton object just did something impossible. It charged straight at the sun at 150,000 miles per hour and survived completely intact. No curved orbit, no breaking apart. Just a perfectly straight trajectory that defies everything we know about how space works. Now, some scientists are asking a disturbing question. What if 3I/ATLAS isn't a comet at all? What if it's a probe deliberately sent through our solar system, and we just watched it complete its mission? Let's dive right in. When NASA's Asteroid Terrestrial Impact Last Alert System first locked onto this object in July 2025, the astronomers monitoring the data knew immediately something wasn't right. Within days of tracking its movement, they confirmed what seemed impossible. This wasn't just another space rock passing through our cosmic neighborhood. This was something that fundamentally broke the rules. Think about how gravity works for a moment. Every object in our solar system dances to the sun's gravitational pull. Planets trace elegant ellipses. Comets swing around in graceful arcs, their paths bent by the invisible hand of gravity into predictable curves. It's been this way for 4.6 billion years. So when you see an object moving on an almost perfectly straight trajectory, cutting through space like someone drew a line with a ruler, you have to ask yourself, how is that even possible? 3I/ATLAS is doing exactly that. At 130,000 miles per hour, nearly 170 times the speed of sound, it's racing through our solar system on a path that defies basic orbital mechanics. To put that speed in perspective, at that velocity, this object could cross the entire United States in roughly 90 seconds. But speed alone doesn't make something suspicious. What's deeply unsettling is the precision of its course and where that course is taking it. The trajectory brings 3I/ATLAS suspiciously close to Venus, Mars, and Jupiter. Now, if you were an advanced civilization designing a probe to study a foreign solar system, which planets would you prioritize? Venus, with its runaway greenhouse effect that could teach you about atmospheric evolution. Mars, the most Earth-like planet that might harbor signs of past life. Jupiter, the gravitational giant that controls the dynamics of the entire outer solar system. Those three targets would give you a comprehensive understanding of how this particular planetary system works. That's exactly the path 3I/ATLAS is following. But there's another detail that keeps scientists up at night. This object is spinning backward. Almost everything in our solar system rotates in the same general direction because we all formed from the same spinning cloud of gas and dust billions of years ago. Finding something spinning the opposite way is like watching a river suddenly flow uphill. Some researchers have pointed out that this backward rotation could serve a very specific purpose. It might reduce resistance and allow for more precise planetary measurements, the kind of data you'd need if you were mapping an unknown star system. Now let's talk about the sheer mass of this thing, because size matters when you're trying to determine if something is natural or artificial. 3I/ATLAS weighs approximately 33 billion tons. To help you visualize that, imagine the Eiffel Tower, which weighs about 10,000 tons. You'd need to stack 3.3 million Eiffel Towers to equal the mass of this single object. Or consider every car on Earth, all 1.5 billion vehicles on the planet, weighing collectively around 2.25 billion tons. This comet outweighs every car on Earth, combined by a factor of 15. We're talking about the equivalent mass of several major cities made entirely of steel and concrete, compressed into a nucleus measuring up to 3.5 miles across. Some researchers believe it could be even larger, possibly approaching 7 miles in diameter, though that remains unconfirmed. Here's what makes that size so significant. We've only ever detected two other interstellar visitors before 3I/ATLAS, and the comparison is absolutely staggering. In 2017, astronomers discovered Oumuamua, the first confirmed object from another star system to pass through ours. That cigar-shaped anomaly measured just a quarter-mile long, stretched out about 10 times longer than it was wide. Nothing like it had ever been observed. It tumbled through space, accelerating in ways gravity alone couldn't explain, and disappeared before we could properly study it. We had maybe a few weeks before it was gone forever. Then, in 2019, amateur astronomer Gennady Borisov spotted the second interstellar visitor using his homemade telescope. 2I/Borisov behaved like a classic comet: bright coma, long dust tail, predictable behavior. It measured roughly 0.3 miles across and gave scientists valuable insights into how planetary systems form in other parts of the galaxy. It was unusual simply because it came from another star, but otherwise it acted exactly like comets should. 3I/ATLAS is neither small like Oumuamua nor conventional like Borisov. Scientists estimate it's between 1,000 to 100,000 times more massive than those previous visitors. That's not just a difference. That's an entirely different category of object. When something is 3 to 5 orders of magnitude larger than anything we've seen before, you can't simply assume it's just another comet. The scale alone demands a different level of scrutiny. What's even more troubling is what this object is releasing as it approaches the sun. Comets are essentially dirty snowballs, frozen mixtures of ice, dust, and rock. When solar radiation heats them up, the ice sublimates directly into gas, creating those beautiful tails we see. That's normal comet behavior. But 3I/ATLAS is hemorrhaging carbon dioxide and dust at rates that don't match its supposed size and composition. The sheer volume of material being expelled suggests something far more active than a natural comet should be. And here's the kicker. Scientists have dated 3I/ATLAS to approximately 4.6 billion years old, making it potentially the oldest comet humans have ever observed. It originated from the Milky Way's thick disk, a region filled with ancient stars and fewer heavy elements. If this object is truly that ancient, how has it retained so much volatile material? Most comets lose their ice over billions of years. What we're seeing either violates our understanding of comet preservation, or we're not looking at ice at all. October 29, 2025, became the moment of truth. That's when 3I/ATLAS reached perihelion, its closest approach to the Sun, at roughly 130 million miles out, about 1.4 times the Earth-Sun distance. The Sun blocked our view from Earth during this critical period, so we couldn't observe what happened directly. Everyone in the astronomical community was holding their breath because comets often don't survive close solar encounters. The intense radiation and gravitational stress frequently cause their nuclei to crack, fragment, or completely disintegrate. Even large, stable comets can break apart under those conditions. When 3I/ATLAS emerged from behind the Sun, scientists expected damage. Maybe fragmentation, perhaps unusual jet activity or significant mass loss. A blog post even circulated briefly claiming the comet had broken into at least 16 pieces based on photographs from small telescopes in Spain. But when astronomers analyzed the actual data, they found something remarkable. The nucleus looked completely intact. No fragmentation, no structural damage. Just a healthy, whole comet that had somehow survived conditions that destroy most natural objects. Think about what that means for a moment. A 33 billion-ton object supposedly made of ice and rock, held together by weak gravitational forces, passed close to the Sun and came out without a scratch. Combined with the straight trajectory, the backward spin, the chemical anomalies, and the precise planetary flybys, you start to see why some scientists are asking questions they never thought they'd seriously consider. For the first time in modern astronomy, credentialed researchers at major institutions are publicly stating that the artificial probe hypothesis deserves genuine investigation. These aren't conspiracy theorists. These are career scientists who understand that extraordinary claims require extraordinary evidence. But they also recognize that dismissing the possibility without thorough analysis would be unscientific. Their logic is straightforward. If an advanced civilization wanted to study our solar system, they'd need to send something large enough to survive the interstellar journey and carry sophisticated instruments. It would need to move fast to complete its mission within a reasonable time frame. It would require a trajectory bringing it close to scientifically interesting planets, and it might deliberately disguise itself as a natural object to avoid detection or interference. 3I/ATLAS matches every single criterion. Right now, telescopes around the world are monitoring it continuously, searching for technological signatures, unusual radio emissions, electromagnetic activity, unexplained course corrections. So far, nothing definitive has been found, but the absence of obvious signals doesn't rule out technology designed specifically to remain hidden. We're essentially looking for something we've never encountered before, using detection methods designed for phenomena we already understand. As 3I/ATLAS heads toward its closest approach to Earth on December 19th, 2025, staying safely 150 million miles away, scientists have a limited window to gather every possible piece of data. A powerful telescope in Italy is streaming live footage for free, so anyone can watch this mysterious visitor in real time. Researchers are analyzing its spectrum, measuring its rotation, tracking even the smallest changes in brightness or trajectory. Because after December 19th, this object will continue its straight path out of the solar system, and will likely never see it again. This is our only chance to determine what it really is. If it's natural, studying it will revolutionize our understanding of how objects migrate between star systems across billions of years. The stark differences between 3I/ATLAS, Oumuamua, and Borisov already suggest that interstellar visitors have been traveling through the galaxy throughout its entire history. But if there's even a possibility, however small, that this is something built, something sent with purpose, then we're living through one of the most significant moments in human history. And the terrifying part? We might not even realize it until it's too late to ask the right questions. So here's what we know for certain. A 33 billion-ton object just survived a close solar pass that destroys most comets, traveled on an impossibly straight trajectory, spun backward, and flew precisely past the planets any intelligent civilization would want to study. Natural comet or technological probe? Scientists still can't give us a definitive answer, and that alone should tell you how unprecedented this situation is. What we're witnessing right now is either the strangest natural object ever discovered, or the first confirmed evidence that we're being observed. Either way, this changes everything we thought we knew about what's possible in our universe. The window to study 3I/ATLAS is closing fast. After December 19th, it'll continue its journey out of our solar system, and we'll likely never see it again. We're living through a moment that future generations will study in history books, and most people don't even realize it's happening. So what's your verdict? Is 3I/ATLAS a cosmic coincidence, or are we watching an alien probe complete its mission? Drop your thoughts in the comments. I read every single one, and this community's insights are genuinely valuable. If you want to stay on top of every update as this story develops, subscribe to Galactic Breaking News and hit that notification bell so you don't miss a single discovery. Give this video a like if it made you question what else might be out there, and share it with anyone who's ready to have their mind blown. The truth is out there, and we're going to find it together.